Hi students, welcome to Physics A level classes. Today we are going to discuss the previous year question paper of Unit 1 in October 2021. It is the last part video. Okay. Uh, so question 17. The water is dropped into a container of oil. The water forms a spherical droplet that moves slowly down. Okay. The droplet moves downwards at a constant speed. The flow of oil around the droplet is laminar. Okay. First of all, what about the situation? It is just like a spherical ball is moving vertically downward through a particular fluid. Okay. And since they are saying that it is moving with the constant speed, so it means the droplet achieves its a terminal velocity. Okay, that means there is no resultant force acting on the droplet during its motion. Okay, that is why it is a uniform motion. Uniform motion. Okay, the velocity of a object which is in uniform motion is called the terminal velocity. Okay, for in order to achieving the terminal velocity, the resultant force acting on the body, it should be zero. Resultant force should be zero. Okay, then it is then we have to define, state what is mean by laminar flow. Okay, what do you mean by laminar flow? Laminar flow, it is a type of flow where the fluid layers are moving parallel to each other. There is no intermixing of fluid layers taking place. Okay, that is called the laminar flow. Okay, so we can define it. It is a fluid flow in which the fluid layers move parallel to each other and do not cross each other. Okay, that means the velocity of the fluid flow is same at a particular is each and every point. Okay, they're moving parallel to each other. Okay, then from this figure it is clear that the first type of flow shows it is not a laminar flow. Okay, after touching our a particular body, what happens, that means in this area the fluid layers are intermixing. Okay, so their velocities are changes, different fluid layers has a different uh, velocity. Okay, so it is not a laminar flow. Okay, but in the second case, the each and every layers are moving parallel to each other and there is no intermixing. Okay, intermixing of layers taking place, so it can be treated as a laminar flow. Okay, then second, state the condition necessary for the speed of the droplet to be constant. Okay, why the we can take this example as the flow of a droplet. This ball can be treated as a spherical droplet. Okay, why the speed of the droplet remains constant, or how we can say that a droplet is moving with the uniform linear motion. This is just because of there is no acceleration is acting on, there is no acceleration is acting on the spherical ball or spherical droplet. Okay, why there is no why there is no acceleration? It is just because according to the Newton's second law, there is no resultant force. Okay, there is no resultant force. Okay, so that means the necessary condition for the speed of the droplet to be constant. That means the droplet is moving at a constant speed, means the resultant force acting on the droplet is become zero. Okay. Now we can take it as a droplet. Okay. Then what are the forces acting on the droplet? Okay. First, we can take the droplet has a upthrust force by the oil. Okay, it is the upthrust force offered by the oil on the droplet. Okay, second one, it is a drag force. Okay, it is a drag force. It is absolutely due to the viscosity of the oil. It is due to viscosity of the oil. And lastly, it is a weight of the droplet. Okay, the weight of the droplet is always acting vertically downward. Okay, always acting vertically downward, and the upthrust and drag force or the frictional force due to the viscosity are acting always upward direction. Okay, If this the sum of upthrust force and the viscous force is equal to the weight, then it becomes then there is no resultant force. That means there is no acceleration is acting on the droplet. So we will get the motion of the droplet into a constant speed motion. Okay, so we can write the condition. Okay, the condition as W minus EF is equal to 0. Okay, where why we are taking the W as positive, since our droplet is moving downward direction. Droplet is moving downward direction, so it can be taken as positive. So the forces acting in the motion in the direction of motion, we can take it as positive. That is W minus U minus F should be 0. That is the resultant force is 0 in this case. Okay. Then question the B part. A spherical droplet has an volume of 3.35 into 10 to the power minus 8 meter cube. That means they are given the volume. Okay. Then calculate the weight of the droplet. They are given that the density of water is equal to 1 into 10 to the power 3 kilogram meter cube. Okay. So how we can take this part? Okay, we know that the density. What about the density? Density of water drop. Okay, water drop, it can be defined as the mass of the water droplet divided by volume. Okay, from that we can write as the mass of the water droplet is equal to density of water droplet. Density of water droplet into volume of the water droplet. Okay, actually they are given that the density of water and the volume of the water droplet, so we can easily find out the mass of the water droplet. Okay, mass of the water droplet is equal to density of water is multiplied with the volume of the water droplets. Okay, so we will get easily the mass of the water droplet. Okay, so then how can we find the weight of water droplet? Weight is equal to mass into acceleration due to gravity. Okay, mass into acceleration due to gravity. So we should substitute instead of the mass of the water droplet and 9.81 is the acceleration due to gravity. So we can easily find out this weight of water droplet. Okay, this is the weight of water droplet. That is 3.29 into 10 to the power minus 4 Newton. Then next part, show that the upthrust on the water droplet when it is completely submerged in oil is about 3 into 10 to the power minus 4 Newton, where there is given density of oil is equal to 0.94 into 10 to the power 3 kilogram meter raised to minus 3 meter per kilogram per meter cube. Okay. How we can find out the upthrust force acted by the oil on the water droplet. Okay, the upthrust force on the droplet which can be denoted by the letter U, which is nothing but the weight of oil displaced by the water droplet. Okay, the weight of oil displaced by the water droplet. Okay, now we have to find out the weight of oil. Okay, what about the weight of oil? How we can find out the weight of oil? The upthrust force on droplet is equal to the mass of the oil into acceleration due to gravity. Okay. In order to find out the weight of the oil, we should multiply the mass of the oil with the acceleration due to gravity. Then next step is nothing but how we can find the mass of the oil. Okay, how we can find the mass of the oil? Mass of the oil is nothing but it is the density of the oil. Okay, already we did we use the expression that is mass is equal to density into volume. Okay, that is the density of the oil into volume of droplet. Okay, why we are using the volume of droplet? Because the volume of oil displaced is equal to the volume of water droplet. Okay, that is the important factor here. Okay, the volume volume of oil displaced volume of oil displaced is absolutely equal to the volume of droplet.
Okay, that's the same thing. Okay, so we can easily find out the mass of oil, that is density of oil into volume of the droplet into acceleration due to gravity. Okay, now we know all the values, that is upthrust force is equal to density of oil into volume of water into volume of uh, into acceleration due to gravity. Okay, now we can substitute instead of the density of oil, it is given that 0.94 into 10 to the power 3, and the volume of water droplet, which is equal to the volume of oil displaced. Okay, the volume of oil displaced, which is equal to 3.35 into 10 to the power minus 8 meter cube, and acceleration due to gravity is 9.81. So we will get the upthrust force is equal to 3.09 into 10 to the power minus 4 Newton. Okay. Calculate the terminal velocity of this water droplet in the oil. The viscosity of oil is equal to 0.11 Pascal second. Okay. In order to find out the terminal velocity, we should know about the Stokes law. Okay, Stokes law. Okay. Then first of all, we have to consider the free body diagram of droplet. Okay, what are the forces acting? What are the forces? Mean the weight is acting. The weight of the droplet is acting vertically downward. Upthrust force and drag force or frictional force due to the viscosity of oil is acting upward direction. Okay, in order to achieve the terminal velocity, that means the constant velocity, constant speed, the resultant force should be zero. Okay, first of all, we can consider first condition. Okay, the condition for achieving the terminal velocity is nothing but the resultant force equal to zero. That is weight minus upthrust thrust force minus the drag force equal to zero. From this expression, we can find out the drag force. Okay, drag force due to the viscosity of oil. Okay, how we can find W minus U is equal to the weight of the droplet minus the upthrust offered by the oil onto the droplet is equal to the drag force. Okay, in previous part we already calculate the value of weight of the droplet and upthrust acting on the droplet. Okay, so we can find easily the drag force, that is 3.29 into 10 to the power minus 4 Newton is the weight of the droplet. 3.09 into 10 to the power minus 4 Newton is the upthrust on the droplet. So we will get the drag force is equal to 2 into 10 to the power minus 5 Newton. Okay, so now we have to recall the Stokes law. Okay, Stokes law. What do you mean by Stokes law? The Stokes law is states that the viscous force offered by an oil to a spherical ball is equal to viscous force F is equal to 6 pi eta RB, where eta is the viscosity. Okay, the eta is nothing but the viscosity. R is the radius of the sphere, and V is the terminal velocity. Okay, it is the terminal velocity. It is the terminal velocity. R is the radius of the spherical sphere. Okay, eta is nothing but viscosity. Viscosity. Okay. So, from this expression, now we already calculate the viscous force offered by the oil. Okay, so we can easily find the value of velocity. Okay, velocity is equal to nothing but we have to divide, that is V is equal to F divided by 6 pi eta R. But now we know the value of viscous force, and we know the viscosity value, it is nothing but 0.11 Pascal second. Okay, and we have to find out the value of radius. Okay, radius of the droplet. Okay, spherical droplet. Okay, how we can find? They already given the volume of droplet. Okay, the now we are considering the droplet as a spherical shape. So volume is equal to 4 by 3 pi r cube. Volume is equal to 4 by 3 pi r cube. Okay, from here we can find out the, we know that r cube is equal to 3 into vw divided by 4 pi. Okay, so r is equal to cube root of 3 into volume of the droplet divided by 4 pi. Okay, now we have to substitute the non values, that is r is equal to cube root of 3 into volume of the droplet is given. Okay, it is given, this is given value. Okay, so we will get the r is equal to 2 into 10 to the power minus 3 meter. 2 into 10 to the power minus 3 meter. Okay, So now all the values are known. Then we have to substitute the known values into this equation. That is v is equal to f divided by 6 pi eta r. Then we will get the terminal velocity. Okay. Terminal velocity is equal to it is 2 into 10 to the power minus 5 Newton. It is the drag force, which is already we calculated by applying the resultant force equal to 0. And the it is nothing but the viscosity is given and the radius of the droplet. Okay, finally we get the terminal velocity v is equal to 4.82 into 10 to the power minus 3 meter per second, right? Then question 8, the diagram shows a system used to move a stone block up a ramp. A team of people uses a rope to pull the block at a constant speed. Okay. Then height of the ramp is 4.35 meter. Angle of ramp to the horizontal is 6 degree. Mass of the block is given 2 into 10 to the power 3 kilogram. The speed of the block up ramp 0.45 meter per second, and the total power of the team is given 6.25 kilowatt. Okay. What about the first part? Show that the total force that the team exerts on the block is about 14 kilonewton, right? First of all, we have to calculate the force applied by the total team. Okay, they've already given what the power is given and the velocity is given. Okay, we know that what do you mean by power? Power is nothing but the rate of doing work. Okay, work divided by time, right? Okay, then what about the work done by a force? It is nothing but the force into change in distance or displacement. Okay, divided by time. Okay, from this we know that the displacement by time is nothing but velocity. Okay, so we will get the power is equal to force into velocity. Okay, but in this question, they're given the value of power and they're given the speed of the movement of block. Okay, now easily we can find out the force applied by the team. Okay, that is the ratio of power and velocity. Okay, so it is very clear that the power is equal to force into velocity. Okay, so the force exerted by the team, F is equal to power divided by velocity. Okay, everything is given. Okay, power is equal to 6.25 into 10 to the power 3 watt. Since they are given in kilowatt, we should convert it into SI unit. That is 6.25 into 10 to the power 3 watt divided by velocity is nothing but 0.45 meter per second. Okay, finally you will get the force applied by the team is equal to 13,888.8 Newton. Okay, so it is nothing but if we are converting it into kilonewton, you will get F is equal to 13.88 kilonewton. F is equal to 13.88 kilonewton. Next part, determine the work done by the team. Okay, how you can find the work? Work is nothing but it is work is equal to force into displacement, right? Force into displacement. First of all, recall the free body diagram of the situation. Okay, force is already we calculated from the given power. Then work done first, then we need the displacement. Okay, that means how much distance the block is moved by the team. Okay, that means the total. Okay, what about the displacement? The displacement is the, if we are considering this it is a right angle triangle whose hypotenuse represents the displacement of the block. Okay, displacement of the block. And from this right angle triangle we know the whose height and the angle and the hypotenuse. Okay, then just applying the sine 6. Okay, we know that the work is equal to force is equal to F into displacement, force into displacement. Okay, from this right angle triangle it is clear that the sine 6 equal to sine 6 equal to opposite side by hypotenuse. And what about the opposite side? It is the height. Okay, that is 4.35 meter. Okay, divided by the hypotenuse, nothing but it's the displacement. Okay, So S is equal to, it is nothing but 4.5 meter divided by sine 60. Okay. Now we know that the work done is equal to F into force into displacement. Okay. Already we calculate the value of force. It is 13 point. It is 13.88 kilonewton into the displacement is already we got it. That is 4.35 divided by sine 6. Okay. So finally we will get the work done by the team is equal to 578 kilojoule. Okay. Then the next two part show that the useful work done on the block is about 90 kilojoule. What about the useful work done? That means if you are applying some work, the work done should be increase the energy of this block. Okay. Now we are checking how much energy of the block is increased. Okay. Initially it is in the ground state. Okay, ground state, and by using this team of people, they are applying a constant force, and they raised our block from the ground level to a particular height of 4.35. Okay. Then in account with the energy of the block, which energy of the block is increased? Okay, actually it is increased, its potential energy. The potential energy of the block is increases. Okay. So we now the useful work done is equal to nothing but increase the energy of block. Okay. Here the increase of energy of block means it is nothing but it is a potential energy of the block. Okay. So the useful work done can be treated as the increase in potential energy of the block. So we can find easily by the useful work done is equal to mgh, mass into acceleration due to gravity into the height, or height in which the block is raised. Okay. So what about the height? Height is equal to 4.35 meter. Okay. So we can easily calculate the useful work done as substituting the mass of the block, that is 2.1 into 10 to the power minus 10 to the power 3 kilogram, and 9.81 is the acceleration due to gravity, and it is the height gh. Okay. It is the height h is equal to 4.35 meters. So finally you will get a useful work done as 8,000 614 joule. Okay. So we have to convert it into kilojoule. So you will get the useful work done is equal to 89.6 kilojoule. Okay. Next part, the determine the efficiency of the system. Okay. Actually efficiency means it's nothing but is the output divided by input. Okay. So the efficiency can be defined as useful energy output divided by total energy input. Okay. In this case, in this particular situation, what about the useful energy output? Useful energy output is nothing but it is the energy increase of our block. Okay. Energy increase of block. Then what about the total energy input? It is nothing but it is the work done by the team of people. Okay. It is the work done by the team of people. Okay. So the efficiency can be defined as it is nothing but it is a useful work done divided by work done by the team. Okay. Both values are already we calculated. Okay. So the efficiency is equal to 89.6. It is the useful work done. That means the energy increase, the energy of the block increased, and 579 for 578 kilojoule, it is the work done by the team. Okay. So you will get the efficiency of the system is equal to 0.155. Okay, now we are going to the last question, question 19th question. Okay. A large parasol has been set up on a windy day. The center of gravity of the parasol is vertically above the center of the base. Okay. The bottom of the parasol starts to lift from the ground as shown. The weight of the parasol is 110, 110 Newton. Okay. Then the force of the wind is 40 Newton in a horizontal direction. Explain why the parasol will topple. Your answer should include a calculation. Okay. First of all, what do you mean by center of gravity? The center of gravity is nothing but it is the whole weight of the body is acting through a particular point. Okay, that point is called a center of gravity, right? And uh, why the stability of the parasol is lost, or why it is moving? It is the equilibrium, which is just because of it lost its equilibrium position. Okay, equilibrium position. Okay, so why its equilibrium position? Actually, there is two forces are acting in this system. One is the weight of the body. Second one is an applied force, that is the force of wind. Wind force is applied on it. Okay, due to that, actually this parasol is moving with respect to this point, this corner point. Okay, it is just rotating. Okay, it is just it has a tendency to rotate about this point. Okay, so you can take it as this point as point O. Based upon the point O, the corner point, the parasol just has a tendency to rotate. Okay, so which is the basic cause of rotation? It is nothing but the moment due to a force, right? Actually, in this condition there are two forces. First one is weight, second one is the wind force. Okay, so actually there exists two moment. Okay, actually there exists two moment. What are the moments? The moment due to the weight of the parasol and the moment due to the wind force. Okay, so first of all we have to calculate these values of this moment and whose directions, right? Okay, the moment about any point is equal to the force into perpendicular distance. This is the way to calculate the moment about any force. Okay, then the moment about any point, that means we are taking a reference point as the point O, that is the corner point of the base, right? This is just because of that whole body is has a tendency to rotate about that point. Okay, right? So force into perpendicular distance is will give the moment of a particular force. Okay. First of all, we are going to calculate the moment of weight about the corner. Okay. Weight is basically acting through the midpoint. Okay, that is through the center of gravity. So the weight is given already. They're given the weight, that is 110 Newton. Then what about the perpendicular distance? It is the just half of the base distance. Approximately, it is the half of the base distance. That is 0.22 meter. Okay, so you will get the moment due to the weight of the parasol about the corner point is 24.2 Newton meter. And then now you have to find out the whatever its direction of rotation. Okay, the moment due to the weight, about the point O, it is acting just in this direction. It has a tendency to rotate in clockwise direction. If you are placing a clock in this direction, then it will be in the direction of its motion of the hand. Okay, rotation of the hand. So it can be treated as a clockwise rotation. Okay, it provides the moment of weight about the corner, provides a moment 24.2 Newton meter in clockwise direction. Okay, right? Now we are checking what about the moment of wind force about its corner. Okay, so it is nothing but again the force into perpendicular distance. What about the perpendicular distance between the corner point O and the wind force, line of action of the wind force? It is the perpendicular distance, the height. It is nothing but 1.8 meter, right? So the moment of wind force about the corner is equal to 14 into 1.8 meter. So you will get a value. The moment of wind force is equal to 25.2 Newton meter. Okay, then what about its direction of rotation? Okay, what about the direction of this wind force, moment of wind force? Okay, if you are placing a clock here, and if you are looking just about the point O, how it the hands rotates or moves by the application of the wind force, it is just opposite to the rotation of clock hand, that is anti-counterclockwise direction. Okay, now we have two moments. Actually, what is the tendency of moment? The tendency of moment is nothing but it is rotational tendency. Okay, then we can calculate the net moment or resultant moment. Resultant moment is nothing but the moment due to the wind force and the sum of moment due to wind force and moment due to the weight of the parasol. Okay, then now we can calculate the resultant moment, that is moment due to the wind force. We can take it as a positive direction. Since it is a counterclockwise direction, we can take it as positive. Then if it is positive, then obviously the moment due to the weight is clockwise direction, which should be negative. Okay, so you will get a net moment, that is 1 Newton meter moment as a net moment, and it is acting in counterclockwise direction. Okay, That means in this system there is a net moment 1 Newton meter in counterclockwise direction. So it is clear that this system should rotate in counterclockwise direction just due to 1 Newton meter resultant moment. Since there is a resultant moment in counterclockwise direction, the parcel will topple. Okay, the parcel will topple. Then the last part of this question, to prevent the parcel from toppling, a rope is attached to the parcel at 1.5 meter from the ground as shown. Okay, the rope makes an angle 44 degree to the vertical. Okay, the horizontal force of the wind is now 25 Newton, determined by taking the moments about the center of the base, the vertical force that the base exert on the ground. The vertical force we have to find out, the vertical force that the base exert on the ground. Assume that the force which the ground exert on the base acts through the midpoint of the base. Okay, right? Now we have to analyze this system, right? Then what are the forces acting on this system? First one, the weight of the parcel, that is, it is always acting through the center of gravity. Okay, and that says that the center of gravity is just a midpoint. Okay, midpoint of the base. Okay, midpoint of the base. So the weight is acting through the midpoint of the base, right? Then second force is the wind force, right? It is a wind force. Then a third one is we already by using a rope we provide additional prevention by using a rope. So it is nothing but the tension of the rope. Okay, it is a tension of the rope. Okay, right? Tension of the rope. Actually, the tension of the rope is at a particular angle, that is 44 degree inclined with the vertical. So we can resolve this tension into horizontal and vertical component. Okay, how we can resolve a force? Okay, if we are taking it as a tension, right? Then it is a horizontal component. Okay, and it is a vertical component. Okay, so it is a horizontal axis and it is a vertical axis. If our tension is making an angle with horizontal vertical is as theta, then the vertical component will be t cos theta, right? T cos theta, and the horizontal component will be t sin theta. Okay, it is absolutely depend upon the angle. Okay, where from where the angle makes. Okay, that is here the tension makes an angle theta with respect to the vertical axis. So cos component will be in vertical and the sin component will be in horizontal. Okay, right? So similarly we can resolve this tension into horizontal and vertical. Okay, that is t cos 44 is acting vertically downward. Okay, since the tension also in vertically downward direction. Okay, downward direction. So you will get the vertical component of this tension is t cos 44. And what about the horizontal component? Okay, the horizontal component of the tension is t sin 44 in horizontal direction towards the right direction. Okay, towards the right of the system. Okay, so now the total number of force becomes one is the weight, second one is the vertical component of tension, third one is the horizontal component of tension, and last fourth one is nothing but is the wind force. Now there are four forces. Okay, now there are four forces. Now we have to actually, why we are provide this rope? Okay, this rope is absolutely to prevent the toppling of this parcel. That means to keep the parcel in equilibrium condition. Okay, that means there is no net forces and net moments, because the parcel in a equilibrium position, equilibrium, or in, or which is in a rest, there is no resultant forces are acting all and also there is no resultant moment also acting. Okay, that means it has no translatory motion as well as no rotational motion. Okay, there is no motion at all in this system. Okay, so we can take the moment about this center point. Okay, center point. Why we are taking this center point? Because the all the two vertical forces are passing through that point, right? Okay, So we know that the moment about this point, a moment about this point, that is the center of the base, the moment of weight about this point, and the moment of t cos 44 about this point is 0. Why the moment about this point is 0? For those forces, that is for weight and t cos 44, we know that the moment is nothing but it is the force into perpendicular distance, right? Perpendicular distance. Actually, the line of action of the weight and the line of action of t cos 44 are passing through this point. So there is no vertical, sorry, so there is no perpendicular distance. Okay, there is no perpendicular distance. That's why the moment due to the weight as well as the moment due to t cos 44 about the point midpoint of the base will be 0, right? So first of all, we can conclude that the moment of weight about the central point equal to 0, and the moment of t cos 44 about the central point equal to 0. Okay. Then only two moments are existing with respect to the center of the base. What are the moments? The moment due to t sine 44 and the moment due to the wind force 25 Newton. Okay. Now we are going to calculate that what? Since the parcel is in equilibrium, the resultant moment will be 0. That means moment due to t sine 44 should be equal to the moment due to the wind force. Otherwise, it will rotate. Okay, if there is a resultant moment, the total system has a tendency to rotate. Okay, since they in this question they specifically says that our system is in equilibrium, that means there is no motion, so the net moment will be 0, the resultant moment will be 0. That means now there is only two moments, and that moment should be equal and in opposite direction. Okay, right? So it is clear that t sine 44 is acting towards the right direction, and the moment about this central point is due to this t sine 44 is in clockwise direction, and the moment of wind force about the point O will be in anti-clockwise direction. Okay, that is counterclockwise direction. Okay, so it is clear that they are acting in opposite direction, and their magnitude should be equal. Then only resultant moment becomes 0. Okay. So that means if we are considering the equilibrium conditions, the moment of wind force that is acting in counterclockwise direction should be equal to the moment of t sine 40. Okay, sine 44 in which is acting in clockwise direction. Okay. So we are considering the free body diagram and considering the net moment, equality of moment due to the wind force and the horizontal component of the tension, moment due to the horizontal component of tension. Okay. So it is nothing but the moment due to wind force is equal to force into perpendicular distance, right? Force is 25 Newton and perpendicular distance is 1.8 meter from the midpoint of the base, okay, towards the line of action of the wind force. Okay, then moment of the tension, horizontal component of tension is t sine 44, that is t into sine 44 into the perpendicular distance between the central point and the line of action of horizontal force of horizontal component of the tension is 1.5 meter. Okay, so you can easily find out the unknown value, that is the magnitude of tension. Okay, magnitude of rope tension. Okay, how you can find it? You have to divide sine 44 into 1.5 meter. Okay, with 25 into 1.8 meter. Okay, so you can easily find out the tension value. Okay, finally you will get the value of the tension of the rope as 43.19 Newton. Okay, then what we have to find in this question? Okay, we have to find the total vertical force acting to the ground through the base. Okay, what are the vertical forces acting in this system? There are two vertical forces are acting. One is the vertical component of the tension, and the other one is the weight of the system. Okay, so the vertical force that the base exert on the ground is nothing but it is the sum of t cos 44 plus weight of the system. Okay, We know that the tension, we already calculate the value of tension, that is 43.19 into cos 44, that is the horizontal component of the tension, sorry, vertical component of the tension, and we already know the weight of the system as 110 Newton. Okay, so you will get the total vertical force Vf is equal to 141.1 Newton. Okay, thank you so much. Now we complete the October 2021 previous year question paper related to the unit 1. Okay, thank you so much.